It is not the scheduler that actually gives control of the CPU to the next process. That job belongs to the dispatcher. The dispatcher module is going to give control of the CPU to the process that was just selected by the CPU short-term scheduler. The steps involved in that include switching the context. So that means we're going to have to write the contents of that process control blocks registers back into the registers for the CPU. And then we would need to make sure that we have updated the stack pointer. And we're going to need to make sure that we switch into user mode, which is not something that we've emphasized before. But it's important to make sure that the CPU is going to switch into user mode because otherwise we have some process running with operating systems privileges. The very last step is when we set the program counter to the appropriate location in the user program. So if it's already run some, that might not be at the beginning of the program. It would be whatever the saved value of the program counter is in the process control block. The time it takes for the dispatcher to stop one process and start another running is called the dispatch latency. We can think of that as the time it takes to perform an entire context switch.